Alright, so here we are with imaginary numbers. So, the idea of imaginary numbers, or eventually what we'll talk about, which is complex numbers, the idea is that whenever you have a quadratic equation, so something with a squared power, you end up having the option of two zeros. Okay? The problem becomes when you end up having a quadratic equation that doesn't actually go through the axis. The interesting part about that is that because you have an x squared to make this equation, you have this option of two zeros. And so even though this one comes from a squared as well, you still have an option of two zeros. We just need another number set to get you those zeros. So in this case, up here, this is where we end up having imaginary numbers so that we can talk about the two solutions that exist. So, interesting, kind of a weird concept, but that's the idea. Imaginary numbers allow you to have all of the zeros that you need given the power of an equation. So, in order to talk about where imaginary numbers come from here, I'm going to draw us a little diagram of the number systems. So, first thing that we're going to talk about is our real numbers, okay? Because the real numbers are what we've been dealing with all along. All right, so real numbers are a lot of times given by the symbol of this fancy R, and so if we've seen that before, that's what it's talking about, the set of all real numbers. Real numbers are made up of what we call rational numbers. And rational numbers are things that can be ratios or fractions. So for instance, a half or 3/2. All right. After rational numbers, of course, we also have irrational numbers. And so irrational numbers are things like pi can't be made into a ratio, or square root of 3 is irrational, or e. We'll talk about that one when we get to logarithms. So these are all part of the real number system. We've got irrational numbers that go on forever, and rational decimals that end up either repeating or ending. Within rational numbers, we also have another set of numbers, and that's going to be your integers. All right, and integers are going to be any of your negatives or positives. So we've got the set of, for instance, -1, 0, 1, 2, all of the integers that are possible there. Within integers, we have something called whole numbers. And whole numbers include 0. And then only positive numbers after that. And then all the way inside of that are your natural numbers. And so 0 is not included in there. So again, all of this is your real numbers, hopefully numbers that you've seen so far. Okay? Now outside of this, we have imaginary numbers. It's a complete set of numbers that does include all rationals and irrationals, but the new thing is that you have an I involved. And I actually equals the square root of -1. All right, and so when you use the value I, it can allow you to take the square root of a negative number. If you've up until now tried to take the square root of a negative number, you would have in fact gotten something that says like invalid dimension or error or something, okay? But what happens is now you can actually take out that negative and insert an I, and then you actually get whatever number you need. So you could get 3i, whoops, you could have 1.7i, whatever it happens to be. You get to use all of it. I don't know why that's not working. Okay, there we go. So, within all of this is the fact that both of these together, a real number plus a complex number, or imaginary number, sorry, makes what we are calling the complex number system. And so complex numbers are a real piece plus an imaginary piece. So this is your imaginary, and this is your real. Alright, and so that's what we're going to have as solutions today. So we're either going to have imaginary solutions, because again the equation doesn't physically go through the x-axis, yep, or we're going to have complex numbers. Either way, it's going to have an I involved, and we're going to be able to solve it. So, how do we get to these values? We get to use the quadratic equation. So, going through our quadratic equation, this is when you are set up with something that is a quadratic. So you have an ax squared plus a bx plus a c. And you want to find out what your zeros are. Normally we would go ahead and try to factor, but it turns out that these are going to be for things that are unfactorable, which means that in order to get our x values of these intercepts, we're going to have to do that super duper song. So if you remember what it is, it goes along with pop goes the weasel. So either way, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There it is. So that's your quadratic equation. And again, it comes from this value here as your a, this one as your b, and this one as your c. So just in general, we want to remember, what does it do? And it finds the zeros or x-intercepts or solutions or roots. And they're all the same word, but I like to think of them as x-intercepts. But remember that they also have names like solutions and zeros and roots, etc. Alright, other than what does it do, remember that we need to know why we would use it. So why would I use this? And that's because you don't need to or can't factor. Or you need to find imaginary solutions. Alright, so that's what we're going to do in our first example here from the notes guide. So, taking a look at, we're actually going to do in 1 through 5 here, we're going to see how an imaginary number may come up. So, in number 1, hopefully remember square roots, ask ourselves what times what is going to make that number, and that's 12 in this case. But notice that the difference between this one here and this one here is that we have this little negative, okay? So what does that change? It changes you to think of it as a square root of -1 and then a square root of 144. So if we think of that as two separate pieces, the square root of -1 becomes I, and the square root of 144 becomes 12. We do tend to write the I at the end, just like we would if it was a variable. So 12I is the answer to that one. Same idea for the next one. What's the square root of 49? That's 7, but because there's a negative involved, it's 7I. The last one, we're asking what is the square root of -7, and again, if you try to put that in your calculator, you're going to get an error. But if you understand what we're looking at, you actually just need to do the square root of 7 itself. And that gets you 2.6457. And once you have that, you would tack on an I to take care of the negative piece. Alright, so there it is. So we're going to practice using our quadratic formula. We did just do it in the previous section, but let's go ahead and fill in the fact that there's an a out front of the x squared, a b out front of the x, and a c at the end. And our formula says that we need to do the opposite of the b value, and then take b squared minus 4ac, and all of that over 2 times a. So we'll go through and find our zeros for the equation, and therefore be able to put it into its factors. So taking a look at what we have here, our a value is way out front, it's a 1, a b value of 8, and a c value of negative 16. We've got to be careful that we do include our negatives when they're there. So we're going to fill in the quadratic equation. All right, the first piece is opposite of b, so negative 8, and then b squared, so 8 squared, minus 4 times 1 times c, which is negative 16, and put that over 2 times 1. From there, we go ahead and solve using the order of operations. And so the order of operations says that you need to do parentheses or things inside first. So we're actually going to do this piece inside, which is called the discriminant. So we're going to figure that out first, and then we'll do the square root. So taking a look at what's inside the square root, we have 8 squared, which is 64. And to that, we would end up taking away 4 times 1 times negative 16. And so 4 times 16 potentially is going to give us a positive 64, because negative 4 times negative 16 is a positive. We're still going to have plus or minus 8, and still going to have divided by 2. After that, we can actually simplify, and we realize that it's the square root of 128. And so the square root of 128 and again, not something that you would need to know at the top of your head, so you would just go ahead and use the calculator. So we now have negative 8 that we are going to add, and subtract 11.31 divided by 2. So that means that I'm going to do a negative 8 plus 11.31, all of that divided by 2, and I'm going to do negative 8 minus 11.31, all of that divided by 2. Again, order of operations, do that numerator first. So this first piece becomes 1.66 or 65, but rounded. So that's that top one. And the other solution is going to be negative 9.66. So those are our zeros. Again, this system can be used to find the irrational solutions if you can't come up with them, so something seems unfactorable. And it can also be used to find our zeros that are imaginary. So that's actually what our next example is going to do. So we will go through number 6 as well. So taking a look at number 6, we're going to go ahead and identify our A, B, and C. So our A value is 1, our B value is 2, and our C value is 10. Go ahead and fill that into the equation. So we need opposite of B, which is 2. 2 squared minus 4 times our A value, which is 1, times our C value, which is 10. And all of that over 2 times our A value, which is 1. From here we continue the quadratic equation, and so we're going to have negative 2 plus and minus the square root of 4 minus 40, because 4 times 1 times 10, over 2. If we simplify that a little bit, we are in fact going to get the square root of negative 36 inside. So notice that 4 minus 40 becomes a negative, and so that's where we end up getting our imaginary solution. Officially, that means that we are going to take negative 2 and add and subtract the square root of 36, which is 6i. That's supposed to be an I. That's the ugliest I's I've made. Here we go, 6i. I think it's because my palm keeps touching the iPad when I'm writing. Okay. And that's all still going to be over 2. To help ourselves out a little bit, I am going to introduce or reiterate the fact that if you have something all divided by 2, technically you can take the first piece, which is 2, and divide it by 2, and the second piece, which is 6, and divide it by 2. So if I do that, I'm going to actually get negative 1 plus or minus 3i. So just to kind of simplify it a little bit. Since you cannot add real pieces and imaginary pieces, our first solution is actually going to be negative 1 plus 3i. So this is your complex number, and negative 1 minus 3i. And so those are our zeros. So hopefully you didn't try to change that to like 4 and negative 2i, again, because you cannot add a complex solution together, a real piece and an imaginary piece. So ultimately your assignment is going to be doing this again for 4 other quadratics, so kind of going through those pieces and giving us the zeros. All right.